Now, two important concepts: path function and point function. What is mean by path function? From A to B, we had already discussed that area under the curve. So this is PP diagram. Area under the curve indicates the work done. Now, if this is like this and this is like this, so in the first case, work done is this much, and in the second case, this is this much area under this curve. So this depends on not only the state A and B, also the path, also the intermediate state point between A and B. So this is known as path function, where it is depends on the path. So work done, heat transfer. So work done, heat transfer are the path function. Now point function. Point function means which is only depends on the state of the point. So this A is defined by P and V. So P and V is the point function. So this is the path function, and point function is entropy, enthalpy, pressure, temperature, like this. Now we will discuss some of the common process which generally encountered in the thermodynamic analysis or in any mechanical system. Adiabatic process. When heat transfer is 0, then this is known as adiabatic process. Heat transfer means 0 means we had already discussed delta Q is equal to delta E plus delta W. Now if delta Q is equal to 0, then delta E plus delta W is equal to 0. Means work done by the expense of its internal energy. Delta W is equal to minus delta E. So no heat transfer. So work done by the system is by means of the expense of the internal energy. This kind of process is known as adiabatic process. Now second is isothermal process. Isothermal process, simply temperature is equal to constant. Isobaric process. What is meant by isobaric process? P is equal to constant. When P is equal to constant, then it is known as isobaric process. Then isovolumetric or isochoric. Now isovolumetric, isometric or isochoric, So when V is equal to constant, then it is known as isovolumetric or isometric or isobaric. So adiabatic process, no heat transfer. Isothermal process, temperature is constant. Isobaric process, pressure is constant. And isovolumetric or isometric or isobaric process, volume is constant. Now for the case of ideal gas, try to remember this formula. For ideal gas we generally use PV diagram. So adiabatic process, for adiabatic process, PV, it is look like this. PV to the power gamma is equal to constant, while gamma is equal to Cp by Cv, and work done from 1 to 2. If you perform this integration, work done from 1 to 2, then we will get m Cv T1 minus T2. So for the case of adiabatic process, work done is equal to m Cv T1 minus T2. Now isothermal, we will discuss. We can directly get this formula without this integration PV. Now next is isothermal process. So in this case, it is T is equal to constant. So work done will be from integration PdV. It will come or P1 V1 ln V2 by V1. So basically P1 V1 PV is equal to MRT. So this is this, where T1 is equal to T2. Just remember this formula. This is for isothermal process. Omega work done from 1 to 2 is equal to MRT ln V2 by V1, which is P1 V1 ln V2 by V1. Now consider, so basically PV to the power n is equal to constant for isotropic, for an adiabatic process. In adiabatic, n is equal to gamma Cp by Cv. This is for adiabatic process, and n is equal to 0 for isobaric process. N is equal to 0 means P is equal to constant. For isobaric process, N is equal to 1 for isothermal process. N is equal to 1 means PV is equal to constant. Now PV is equal to nRT, means nRT is equal to constant. Now n and r is already constant, so it indicates T is equal to constant. When n is equal to 1, it is isothermal process, and when n is equal to infinity, then it is isoperiodic process. Isoperiodic process means P is equal to constant. So depending upon the value of n, it is sometimes adiabatic or isobaric, isothermal, and isoperiodic. Then for generalized case, this process is known as polytropic process, when n is another number which is not equal to gamma, not equal to 0, not equal to 1. So this is known as polytropic process, and work done is equal to mRT1 1 minus n P2 by Q1 n minus 1 by n minus 1. So this is the work done. mRT1 1 minus n P2 by Q1 n minus 1 by n. N is the polytropic coefficient, which is also equal to P1 minus P2 by n minus 1. Remember this formula. Now coming to the ideal gas laws. This is PV is equal to nRT, where R bar is equal to universal gas constant, whose value is 8.314 Newton to the power 3 joule per kg mole K. This is not depends on the property of the gas. It is universal gas constant. P is equal to n is number of mole. But we are always interested in the form of mass. That's why we converted this equation to PV is equal to mRT. M is the mass and R is gas constant, which is depends on the properties of the gas. For the case of air, R is 287. Basically, the definition of R is equal to R by M, where capital M is equal to molecular weight. So if you convert this into PV is equal to mRT, then this R is not universal. It depends upon the properties of the gas. For the air, it is 287. Remember this number. And basically, this definition of R is equal to R bar. R bar is the universal gas constant by M. For the M is the molecular weight. For oxygen, it is 32.